In this video, we're going to talk about how to graph polynomials. And before we start graphing, I just want to tell you what polynomial it means, and the meaning just goes back to having multiple x's with different powers in a equation that we have. For maybe y is equal to x to the third plus x to the fourth plus 5x squared plus 3. If we have something like this where we see multiple x's with different powers, because we cannot add them or subtract them, we call these polynomials. Now in this video, we're just gonna learn how to graph those polynomials. And to figure out how to graph them, we need to know some particular graphs, for example, the graph of x to the third power, or the graph of x to the fifth power. And in general, we need to know these because we're going to be using those when we're trying to graph a polynomial. The most important graphs that you need to know are y is equal to x, or we know that this is a line. It's just a line that's going up. And y is equal to x squared, which is a parabola. And we have y is equal to x to the third power, which looks something like this. Now, I know that we talked about these two a lot because we use these two a lot in both math and physics, but x to the third power is also one of those. And I just want to make sure that you guys know that you can always graph this using Desmos, and you will never be asked to graph this when you have a test or something, because it's not something that we learn in algebra or basic algebra. However, again, if you want to know what the graph looks like, you can always use Desmos to give you the actual picture of these. However, you need to know what's going on with all these lines and all these graphs. And the most important things that you need to know are the end behaviors and behavior of all these graphs. And as you can see for this one, the end behavior, we have to look at both ends of our lines or parabolas or whatever that's going on in our graph. As you can see, the end behavior for this one, as x approaches negative infinity, we can see that y is also approaching negative infinity. Now, if you can see it, as x approaches positive infinity, as the value of x is going up, we can see that the value of y is also approaching positive infinity. Now, the end behavior for a parabola, if we don't have any negative signs in front of it, you can see that as x approaches positive infinity, y is approaching positive infinity. Now, you can see that as x approaches negative infinity, y is approaching positive infinity. And that's really important. You don't have to know what the positive infinity and negative infinity means, as long as you know what the graph looks like. However, sometimes teachers want you to know that if x is approaching positive infinity, y is also approaching positive infinity, and all these notations. However, again, if you know what the graph looks like, you don't even have to memorize these, because these come intuitively as long as you know what the graph looks like. Now let's look at this one, x to the third power. You can see that as x approaches negative infinity, we can see that y is approaching negative infinity. And as x approaches positive infinity, we can see that y is also approaching positive infinity. And the most important thing you need to realize is that they match. The x to the first power and x to the third power, you can see that the end behavior, they are matching, and it's because of the fact that they are odd numbers. And the same thing goes to the x to the second power and x to the fourth power. They all have the same type of in behavior, but the way that they're drawn might be different, because if you look at decimals, this is what x to the fourth power looks like, but we don't have to know that for this particular video. However, we need to know what's going on when x is to the first power. As you can see, we cross the x-intercept and y-intercept, just cross it. However, when x is squared, or we have x to the second power, you can see that there's a jump in here and then we go up. It makes that U shape. And as you can see, for x to the third power, for the intercepts, we can see that we're crossing the intercepts. And that's really important when you're trying to draw out your polynomials, because that's going to tell you if the in your intercepts, are you going to cross it or are you going to bounce off? And that all goes back to the power of x, and we're going to do examples for that. Okay, for our first example, we have y is equal to this whole equation. Now, the first thing I want to tell you is that the most important thing when you're drawing polynomials that have this shape is to figure out your x-intercepts, because the only important thing that you need is the x-intercepts. Now, how do we find our x-intercepts? As you know from my previous video, when you set the whole equation equal to 0, or substituting y with 0, it will give us the zeros or the x-intercepts for these equations. However, I just want to show you a really quick way of doing it. You can see that the first x-intercept that we have is positive 2, and it's basically the opposite sign of whatever we see in the equation. So the x-intercept for the first one is 2. For the second one, it should be the opposite sign, which is -3, and should be +4. Now, the second thing that might be kind of important is figuring out your y-intercept. However, for the most part, teachers would not ask you to do that, because it's just the rough sketch that you draw out from your polynomial is the whole thing that they are looking for. So I'm not going to be doing that. But if you're trying to figure that out, you can basically FOIL everything out and figure out what the y-intercept is. Or you can just put a 0 in here, 0 in here, and 0 in here, and just multiply everything out and you'll see the answer. For our first intercept, we have -3. Now, the first thing I would like to do from here, after I figure out my intercepts, is to figure out the end behavior of my whole graph. And again, we can figure out the int behavior by looking at our x's and their power. As you can see, we have 3 x's, and every single one of them have a power of 1, which means, in general, x to the first power plus x to the first power plus x to the first power, it's multiplied, not plus. When we multiply every single one of them out, we get x to the third power, which means that the int behavior should look like something like this, meaning one side should go up, the other side should go down. Now, which side is going to go up and which side is going to go down? We have to look at our leading coefficient. As you can see, the leading coefficient is a positive number, which means that it should look something like this. When it's positive, it means that the whole graph, as x is approaching infinity, y should also approach infinity, which means it should look something like this. Which means whatever is happening after +4, our whole graph should go up, and for -3, our whole graph should go down. Now, let's see how we can basically graph this. As you can see, the first intercept that we have is -3. When I look at -3, we look at the power of x. As you can see, there's no power, or the power that's there is 1. So we know that it's going to cross the -3. Now let's look at -2. And when we look at -2, you can see that the power of x is 1. Again, we don't have any power, so it's 1. And when it's 1, we know that it's going to cross -2, +2. So it should have something like that, because it's crossing it. Now for x minus 4, again, since we don't see anything, it's to the power of 1, which means it's going to cross it. Now, when we're trying to connect all these, we are going to get a curved shape in here and in here. You need to know that you have to make this curved shape in order for this graph to come down and touch +2, and then for this to go up and touch +4. That's why you get this curved shape. However, again, you don't need to know that. You don't need to know why it's happening, but you need to know that it's drawn this way. And as you can see again, because the leading coefficient is positive, it's going to look like y is equal to x to the third power. For our next example, I also want to start with our x-intercepts. As you can see, for the first one, it should be -1. For the second one, it should be +3. And for the last one, should be -2. Now we're going to draw out our coordinate system, 3. Now in this part, where as you can see, we have a negative in front of our coefficient, and we also have different powers. Now, how do we figure out what to do? The first thing you should start with is look at your powers. As you can see, the first one, the power is 1. For the second one, it's 2. And for the third one, it's 3. As we add everything up, 1 plus 2 is 3. 3 plus 3 is 6, which means it should look like is something like this, meaning that both sides of our graph should point at the same direction. And again, since it's x to the sixth power, we know that it's going up. Now let's look at the leading coefficient. The leading coefficient is -4, which means that it should reflect down because it's -x to the sixth, which means it's gonna look like an upside down U. Again, which means the end behavior in the left side should be down, and for the right side also needs to be down. If we start with the first intercept, which is x is equal to -2, we can look at the degree or the power of x, and as you can see, it's x to the third power, which means it should look like something like this. But we don't have to make it look like that, because as long as we know that it's going to cross the x-intercept at that point, that's all that matters. So we're just gonna draw a cross in there, or a line that's going to cross that part. And for -1, as you can see, because the power is 1, we know that it's going to cross it. And for +3, we can see that it's a square, which means whatever's happening in here, it should bounce back. Whatever's happening, it should bounce back, and in here, our graph should bounce back and go down because the power is to the second power. Now we're going to basically connect all these, and as you can see, it looks something like this. And this happens with every single one of them. As long as you know what the initial graph looks like, or what the initial graph for a odd function, which is just a cross, and for an even function, which is just a u, you will be able to basically draw out every single one of them, as long as you know what part is the most important part. Always remember that you should look at your coefficient when you're trying to draw them, because that's going to tell you if the whole graph is going up or if the whole graph is going down. And I want to remind you that this is y is equal to x, and this is y is equal to x squared. And I also want to remind you that this is x to the third power and this is -x to the third power, as you can see, because the values of our y values as x is getting bigger is going to the -infinity. And again, you can always look at decimals when you're trying to figure out what it looks like. However, I believe that if you try to kind of memorize these, you will be fine and you will know how to graph them.